Today we're going to work on parallel and perpendicular lines. Know that we are skipping 2.11 for now. We're going to actually come back and do that on the block. So skipping one lesson and we're starting 2.12. So our objective today is identify the relationship between the slopes of parallel and perpendicular lines. That part's important because that's the main thing we'll focus on. Then be able to write equations that are both parallel and perpendicular. So I do have an opener for us today. I want you to identify the slope of each line and then graph both lines. This is going to be a good kind of segue into what we're doing with our lesson today. So go ahead and hit pause on the video, graph both these lines for the opener, and then again, that'll be a great way to kind of start our conversation about parallel and perpendicular. Okay. All right. So on these left set of equations, one thing we should identify as the slope is that they both have a slope of 3. Graph the lines, there's no x or no parentheses, so the x is 0, so the 7 and -7 is the y-intercept. So this 3x plus 7, that's this top line right here, and the 3x minus 7 is the line down below it. What we're getting at here is that these lines are parallel. They never touch. That is one definition of parallel lines. Okay, lines that will always be the same distance apart, and thus they never intersect. One relationship that we're going to investigate, and we'll make a note about right now, is what do we notice about the slopes of parallel? They're the exact same. Well, that makes sense, right? If we keep using the same rise over run from one point to the next, how would we ever expect for those lines to intersect? Okay. Now the other equation, this slope is 1/4. This slope is -4. Uh, the starting point here is +3, +4, so that's this point right here. And then using a slope of +1/4, we're going up 1, right 4, up 1, right 4, or down 1, left 4. Okay, the other equation has a slope of -4 and a starting point where x and y are both -2. So down over here, and then slope going down 4, right 1, or up 4 and left 1. Now what's happening here is this is what perpendicular lines look like. They intersect, and they intersect in a way where they create 4 90-degree angles. We don't really talk about angles in this class. This is something you'll do more in geometry, but they're intersecting in a special way where they create all these equal angles. So every angle in between the two lines is all 90 degrees. Again, what we're focused on is the slopes. Okay, so 1/4 and -4. Well, if I make -4 a fraction, these slopes, they are called reciprocals of each other. So I can flip the fraction to create the other one, and then they're opposite signs. So one slope is positive, one slope is negative. And that leads us into our definitions and how we identify parallel and perpendicular lines. Okay, so parallel lines are lines that never intersect. The equations of parallel lines will have the same slopes, but they need to have different points. Okay, if they have the same points, then they end up just being the same line. So that different points is a really important piece. Okay, now perpendicular lines that intersect to form 4 90-degree. Another name for 90-degree is a right angle. So 90-degree or right angles. The equations of perpendicular lines will have what's called opposite, which means to switch the sign, and reciprocal slopes. Okay, let's just make a note of what this means. When I say opposite, that means to switch the sign. And when I say reciprocal, that means flip the fraction. Okay, so opposite meaning switch sign, reciprocal meaning flip the fraction. Okay, and then just same as before with parallel, they need to have different points. Well, actually, I guess that's not quite as important because they'll never be the same line because of this. So let's just skip that part. All right, well, our task, we're going to have a few different things, identifying parallel and perpendicular. Make sure you read directions throughout all the notes, and especially when you get to the homework, because every kind of set of problem, we're going to have a different task. So it said, what would the slope of a line parallel to each line given? So we want to identify a line or a slope that is parallel to the given equations. So all these equations, when we're trying to identify a line that is parallel to it, the only thing we care about in these equations are the slopes themselves. So I have a slope of 1/3. Okay, the next line has a slope of 2. And the last one has a slope of, well, that negative. We've had lots of conversations about what that negative represents. Remember, it's a -1. Okay, the rest of the stuff in the equation does not matter for what we're trying to accomplish. We just want to say, what would the lines look like if they're parallel to these? What would the slopes be? Well, the slope of a parallel line that's 1/3 stays the same as 1/3. Slope of a line that's parallel to 2 would also have a slope of 2. And a line that is parallel to -1 would also have a slope of -1. Okay, so quick and easy there. Now, perpendicular. Same idea. If we want to find a perpendicular slope to the given equation, the only thing we care about in the equation is the slope. So the first line has a slope of 3/4. Its perpendicular slope, we're going to do two things to this. We're going to flip the fraction. So 3/4 becomes 4/3. Then we need to take the opposite, which has us switching the sign. Since the slope is positive, the perpendicular slope would be negative. Okay, so you do two things to perpendicular slopes. Let's do it again. -2. Some of you might be, well, how can we flip that? That's why it's important that we remember we can take any number and put it and make it a fraction by putting it over 1. So if I flip -2/1, it becomes 1/2. Since the slope was negative, our new perpendicular slope is positive 1/2. Right, and then the last one, this one's actually kind of trickier. Remember, there's no number in front of the x. When there's no number there, that means we have a slope. That is 1. I want to make that a fraction. That's just 1 divided by 1. When I flip 1 divided by 1, it stays as 1 divided by 1. So the only thing that we need to do to make this perpendicular is multiply it, or change the sign and make it -1. So the perpendicular slope here is -1, or -1 divided by 1. Okay, let's continue our work here and flip the page over. Again, we're going to have different tasks to do with each of these. Okay, and what I'll do with both of these, I'll do the first example of both the parallel and the perpendicular, but here's our task. Write the equation of a line that passes through the given point. This is the given point that we're referring to. It's parallel to the given equation, and we want to write the equation in point slope form. Point slope form being what we see right here. Okay, that's where we have an x and a y coordinate clearly visible in the equation. Okay, so again, in the equation that we're given, we want to write an equation that is of a line that is parallel to this. So from the equation, the only thing I care about is the slope. The rest of that equation does not matter to us. So our new equation, we need to have a slope of -2, since it's parallel, that will keep the slopes the same, and it has to pass through the point of 1, 3. This is our x, this is our y. So in point slope form, it would be y minus 3 equals the slope of -2, and then it'd be x minus 1. X coordinate going right there, y coordinate right here, and our parallel slope right there. Okay? Let's do the perpendicular, and I'll have you do the other examples here. So same task, write an equation of a line that is perpendicular to the given equation and pass through the given point. Write the answer in point slope form. So in the equation here, the only thing I care about is the slope itself. Off to the side, I'm going to figure out what my new slope will be. Since the slope started at -3, when I take the opposite reciprocal, I flip the fraction, that's the reciprocal part, and then opposite sign, so this needs to be positive. So this is our new slope of 1/3, and it needs to pass through the point of 1, 3. That's our x, that's our y. So this equation becomes y minus 3 equals our new perpendicular slope of 1/3 times x minus 1. Okay, slope going right after the equal sign, x coordinate being subtracted from the x, y coordinate being subtracted from the y. Of course, just like we talked about in yesterday's lesson, if we put the y coordinate after the parentheses and write it as +3, that is absolutely okay as well. Okay, I'm going to have you hit pause and see if you can't come up with an equation for b on both 3 and, sorry, I skipped the number 4, so on 3 and 5. Do your best with it. I want you to come up with a guess, even if it's wrong. Coming up with these guesses makes a big difference, so see what you can do. Hit pause and then see what you come up with. Okay, so number 3, part B, our new parallel slope, it just stays as 1/3. Remember, I don't care about anything else in this equation, just its slope. Then we're passing through the point of 5, 3, so that's y minus 3 equals our slope of 1/3 times x minus 5. Then for number 5, part B, again, the only thing I care about here is the slope. I'm going to figure out what my perpendicular slope would be, and I just do that off to the side. So 3/2, I can flip that, making it 2 over 3, and then change the sign. So now it is negative. So our equation is y minus 2, y coordinate being 2, equals the slope of negative 2/3, and x minus 4. All right, well, that's kind of like the big picture here and the problems that I'd say take the most amount of work. Now, we're just going to add a graph to the mix and see if we can't do the same thing that we just did. We're going to write an equation of a line that is both parallel and perpendicular to the line that is graphed, and then pass through the given point of negative 2, 7. So we're going to write two equations. We'll first write an equation that is parallel to this line, then we'll write an equation that is perpendicular to this line. So when thinking about what information do we need? Well, it's the same information we needed in our problems where we were given an equation. We need the slope. Okay, so let's find the slope between or on this line here. When we're finding slopes of lines, we need to pick 2 points where it intersects at nice interval amounts, or excuse me, nice integer amounts, meaning whole numbers. And I'm seeing that on the y-intercept here and then also the x-intercept. Then we're going to find the rise over run. Okay, that is m, our slope, rise over run. I can see that I'm running here by 2 and rising by 1, 2, and 3. One thing that I've asked us to do is think about what should the sign of this slope be. Because if I start on the left side and I start walking to the right, I'm going down, this slope has a negative slope. So it'd be a negative 3/2. Okay, because 3 is the rise and 2 is the run. So now, our parallel equation, it's going to have a slope of negative 3/2 where it stays the same. Its perpendicular slope, we need to flip the fraction and make it positive, taking its opposite reciprocal. So now I know the slope I need for my new line or my new equation, and I know the point. Here's our x, here's our y. So my parallel equation is y minus 7 equals our new slope, which was also the same slope as before, negative 3/2, and then x plus 2. Perpendicular equation, basically the exact same, we just have to use a different slope. So y minus 7 equals 2/3 x plus 2. All right, well, the last thing I'm going to have you all do as part of this video is see if you can come up with the same kind of thing for the second graph here. So go ahead and hit pause. Again, I need you just to try. It does not need to be perfect. You got plenty of space to fix your work below it if you end up getting some ideas that are slightly off here. So go ahead and pause the video and try your best, please. All right, so again, we need to find the slope of the line that is graphed. So finding 2 points where they intersect at integer amounts. I'm seeing a point here at 0, 2, another one at negative 2, negative 2. Then working to find my rise over run, I'm going over 2, that's my run, and I'm rising by 4, making the rise over run or the slope 4 divided by 2, which is positive 2. Now the parallel equation, I'm going to use the same slope as what we had found from the line that was graphed, and it needs to pass through this point. Remember, this is the x, this is the y. So y plus 8 equals our slope of 2 times, in parentheses, x minus 3. And then the perpendicular, exact same, just a different slope down. So that same y plus 8, and it equals the perpendicular slope, which again, if this is 2 over 1, I can flip it and make it 1 over half. Then opposite has us switching the sign, so making it negative 1/2 times the parentheses x minus 3. All right, when you get to the homework, again, make sure you read the directions before you start the questions. But we're all done for the notes. Now you can go and show the sub your completed notes and get going on the homework. Have a great day.